The electromagnetic spectrum is all the different wavelengths that are given off by our atoms when they fall or transfer between energy levels. This is given to you in your data booklet in section 3, so it's not something you have to have memorized, but you do need to know the relationship between energy, wavelength, and frequency. So the way that the spectrum is given to you is based on wavelength. And so this end represents the longer wavelength, and then this is the shorter wavelength. So radio waves have longer wavelength than gamma rays. Energy and wavelength are inversely related, which means the longer the wavelength, the lower the energy. The shorter the wavelength, the higher the energy. And then wavelength and frequency are also inversely related. So the longer the wavelength, the lower the frequency. The shorter the wavelength, the higher the frequency. And so energy and frequency are directly related. So if we were to compare microwaves to radio waves, microwaves have shorter wavelength, higher energy, and higher frequency, which is why they can cook food, whereas radio waves cannot. When electrons are excited to higher energy levels and then return to a lower energy level, they release a photon at a specific energy. And depending on what that energy is, the wavelength and the frequency would determine what type of energy is released, whether it is infrared, visible, ultraviolet, gamma, radio wave. But remember that the electron has to fall in order to emit that amount of energy. Now the 3 types of spectrum that you had in your vocabulary is continuous, where you see all the colors, emission spectrum, which only shows the colors being emitted, so the electron is falling and emitting that energy. Absorption spectrum absorbs the amount of energy as the electron is going up in energy level. So when the electron goes up in level, it absorbs energy. And so that's really the difference between these two. We have blank spaces in absorption, where that energy has been absorbed by the electron. In emission, we have the colored line that shows the amount being released when the electron is falling. Now the spectral line series for hydrogen is typically divided up into 3 sections: the Lyman, the Balmer, and the Paschen. Lyman is when it falls to the first energy level and it gives off ultraviolet light. The Balmer series is visible when the electron falls to the second energy level. And then you have IR when it falls to the third energy level. Again, those were 2 vocabulary terms that you need to know. Now, a lot of times we don't draw circles in DP. Instead, we draw lines. So what we could have, or what you might see, is a series of lines like this. And then it asks you to draw a Lyman series. And so you would have to show electrons falling from higher energy levels down to the first energy level to represent the Lyman. If you were looking at the Balmer series, then you would want to draw the lines going to the second energy level. So here we have the Lyman series and the Balmer series. Now, what hopefully you realized is that as I was drawing those energy levels, or even if we look at the circles, the distance between the circles starts to decrease the farther out you get. And that's what convergence means. Each series of lines converges, so the higher energy levels are, the closer they get together. So again, instead of drawing circles in DP chemistry, we tend to draw lines. And as you draw them, they should be getting closer and closer together. Now, there's not a specific distance that you have to use. You just have to show that the energy levels are getting closer together. So you should be able to draw those energy levels. You should be able to draw what Lyman and Balmer would look like on those energy levels. You also need to understand the relationship with energy, wavelength, and frequency, so that the question might give you a series of lines and ask you questions, let's say that one's C, about them. So it might say, which releases more energy. And so the one that is going to release more energy is going to have the greater distance between them. So in this case, it would be line B, because there's a greater distance there. So then the question might say, which releases higher frequency? And so what you have to remember is that higher frequency means you have more energy. And so the answer here would also be B. So again, showing those relationships. So this question could also have said, which releases shorter wavelengths? And so then again, the answer would be B. Each element, each compound has its own unique atomic spectrum. So it's a fingerprint for those elements. And then you can see some of the elements here. We have hydrogen, helium, neon, sodium, and mercury. Notice that neon tends to be in the, or is in the orange-red line area. So if you think about a neon sign, why does it look like orange glowing light? It's because the electron is giving off a lot of energy, a lot of frequency in that area of red-orange. So we can use atomic spectrum to as one of our ways to figure out what a sample might be made out of.